found by intersection points. In this first one, we have one intersection point, so we're going to have one solution. That ordered pair is 2, -3. Number 1 is done. Our next system has 2 points of intersection with each other, so we have 2 solutions. These are kind of fractional, so bear with me, yours might be a little different. I have -1/2, +1 1/2 for that first point right here. My other point is at 1 1/2, and it's up 3 1/2. There we go, numbers 1 and 2. Number 3, you need to solve the system by graphing. When we solve equations by graphing, you want to look at each equation separately. So let's first look at our parabola. Y equals x squared minus 2x plus 2. Focus only on this equation right now. When we graph a parabola, the first thing we need to do is find our vertex. The vertex is the opposite of b over 2a. -2/2. Our vertex is +1. Sorry, these are positives. +1. Because we know where our graph is going to be vertex, that goes in the middle of our table. We go back some and forward some. So we'll do 0, -1, 2, and 3. It was right here at 1 is our vertex. So plug in values for x to find out y into your equation. So we do -1 squared minus 2 times -1 plus 2, we get 5. With 0 gives us 2, 1 gives us 1, 2 gives us 2, and 3 gives us 5. Plug those values in, go slowly. This is right off the last summative though. So when we graph, we plot our points. -1, 5, 2, 3, 4, 5, 0, 2, 1, 1, 2, 2, and 3, 5. Go ahead and connect your dots. And there is our first equation that we graphed. Next, we need to graph our line, which is not quite in line form, so we're going to have to do some math. We have y minus 2x equals -2. However, we need it in y equals mx plus b form. So we need to get y alone, so let's add 2x to both sides. So we have y equals 2x minus 2. This we can graph. B is -2, so that's where we start. It's our intercept. And then we go up 2 over 1, up 2 over 1, up 2 over 1. And we connect our line. Now here's where it gets tricky. Because our graphing is not perfect, this is our only solution. This point is not exactly a solution. And if you would plug them into the equations, you would see it did not work. But our one solution gives us the point 2, 2. You should always check your solutions though, so let's plug them into our equations. 2 equals 2 squared minus 2 times 2 plus 2. Those would cancel. Yes, it works. 2 minus 2 times 2 equals -2. 2 minus 4, -2. Yes, that works. 2, 2 is our solution. For number 4, we need to solve the system using substitution. So I'm going to set this up 2 different ways, and then we'll solve. For substitution, when we don't have both equal to y, what you do is you take what y equals, you substitute it in for the y. So we would say y, or y is actually x squared plus 1 minus x equals 1. When you're solving for anything with an x squared, we want to get it all on the same side. So let's subtract 1. So it's set equal to 0. We would have cancel and cancel. X squared minus x equals 0 through substitution. However, we can also do substitution another way. Typically, we like it when they both equal y. So let's rearrange this bottom equation so we have y equals. Our top one is already y equals. Now this bottom one, y minus x equals 1. Well, to get y alone, let's add x to both sides. That gives us y equals 1 plus x. So now we have, this equation's gone, y equals and y equals. So you can just set them both equal to each other. And you could say x squared plus 1 equals 1 plus x. We want to do the same thing, get everything on the same side so it's set equal to 0. So we would subtract 1, and we would get x squared equals x, subtract x, and we would get x squared minus x equals 0. Both methods are totally fine. Do whatever makes sense for you. That's all that matters. As long as you understand it, you're good. Now, though, we're at the same point in both problems. Notice we don't have a third term to make the x for factoring. So the next thing we can do is say, what do they have in common? And we see in x squared minus x, they both have an x in common. So let's factor it out. If we pull out an x, we are left with x, and we're left with a minus 1. So that is how our GCF comes out. Once you have it this far, it's just the same thing as if we would have factored. We use the zero product property. So we need to set this thing and our other thing both equal to 0 because one or both has to equal 0 to make our statement true. So we either have x equals 0 and or x minus 1 equals 0. Add 1, x equals 1. So we have two possible x values. However, because we're doing systems, we need ordered pairs for our final answer. So we need to find their y values. I'm going to use this top equation. So if x is 0, y equals 0 squared plus 1, which is just 1. So we have the ordered pair 0, 1. Also, if x is 1, we have y equals 1 squared plus 1, which equals 2. So we have the point 1, 2. If you check your work, they both work out, and there we go. So the last problem was through substitution, which means this time we have to use elimination. Elimination is the one where most people make the most mistakes. I will tell you right now, for elimination, you need two y equals equations. This first one is good. This one needs to have some work. To get y by itself, we need to add 2x to both sides. And so it becomes y equals 2x plus 5. And when I do elimination, I like everything to line up nicely, so I'm going to rewrite my equations. And I'm going to have y equals x squared minus 6x plus 5. I'm going to also have y equals 2x plus 5. Notice like terms are lined up. However, we can't do elimination quite yet because we don't have opposites. We need opposites. Opposites. We must have them. So I'm going to multiply this bottom equation. I'm going to multiply everything by -1. So y becomes negative, 2x becomes negative, 5 becomes negative. Now that we have my opposites, I can go ahead and add my equations together. So I have y plus -y, which is 0, equals x squared plus nothing is x squared. 6x plus -2x is -8x. And 5 plus -5 is nothing. So I'm going to just leave a blank. Right here, I have my x squared equation. And so we go ahead and do just like always, when it's set equal to 0, factor. Can't quite factor, so let's just pull out our GCF, which is x once again. If we pull out x, we're left with x minus 8. Just like last time, set both things of that zero product property, so both things that are being multiplied, set them equal to 0, which gives us x equals 0 and x minus 8 equals 0. If we solve the second one, we would get x equals 8. So we have our two x values. Now we must find our y's. You can use any equation you want, and I'm actually going to use this red one that I had created. So if x equals 0, y equals 2 times 0 plus 5, or 5. So I have the point 0, 5. Next, when x equals 8, I have the point y equals 2 times 8 plus 5, which gives me 21. And so I have the point 8, 21. And here are my two solutions. Double check them back in your equations, make sure they make true statements, and you're done. Next is number 6. With number 6, we have a already graphed system of equations, and so we need to write the system and show that we wrote the system correctly using an algebraic method of solving, which is using either substitution or elimination. When we write our system, start with the easy stuff. Start with writing the equation of your line, because we've done this a lot. So we can write a line. We know a line is y equals mx plus b. B is our y-intercept. In this case, it's +1. And m is our slope. So from this point to here, how did I move? Up or down? I went down 1, right 1. So I went actually negative slope. So one of my equations is y equals the opposite of x plus 1. Next, we need to figure out what my parabola is. I know a parent function for a parabola is y equals x squared. I'm going to go ahead actually and draw that on my graph. So right there, I have y equals x squared. Now I need to figure out how did I move that red parabola to make the blue one they have on the graph for us right here. Notice what happens to every point. This one moved down here, this one moved down here, this one down here, and they all went down in the same amount of function, in the same steps. They all went down by 5. Right here is our parabola's equation. Y equals x squared minus 5. So we wrote our system. Now let's make sure our system's correct and show it algebraically. I'll set up substitution and elimination and then